So this is testing to see if two things are inverses. I like to say it's proving two things are inverses. Let's see if you remember the basics. Do you remember how to get an inverse out of y equals x plus 3? Inverses were all about x's and y's switching around. So, switch the x and the y around. Can I just be done? No. You have to do one more thing. What? Solve for y. Minus 3. X minus 3 equals y, but I like to bring the y to the other side. Y equals works just as good, right? There. Compare this one, compare that one. They're similar, right? And they are inverses. You want to know how to prove they're inverses? You could graph them, but it wouldn't prove it. Graphing them, you would see, though, that they're a flip across that line. Y equals x plus 3 is a line like this that goes through here and has a slope of 1, and it would go just like that. What do you think that looks like when you reflect it over the line? It would go down here and go at the same slope, right? Get how the black and the red one are reflected across the line? That's one way you can tell that they're inverses, but it doesn't prove it. How do we prove it? You have to prove, and you have to do it exactly like this, that f of g of x is equal to, somebody want to predict it? Last hour somebody got it. Yes, g of f of x. The instincts are strong with this one. And then down the two columns, you will simplify until the thing is finally equal to x at the bottom. And if this one equals x and this one equals x, x is equal to x, right? And then you'd be able to prove that not only were they equal to each other, but that they simplified to x. All right, I'm going to give you the two functions that we just had 2 seconds ago. We're going to call this f of x, just to keep the symmetry of the f of x's on the left. It wouldn't have had to been. But I do want you, when you make your proof, I do want you to have it exactly that way. You start with f of g of x, and then you do g of f of x, because that'll make it so much easier for me to follow my notes as I'm trying to grade your test. And if I can't follow you, I'm going to mark it wrong. So try to be like organized with it. All right, so if this is x plus 3, do you remember off the top of your head what was the other one again? X minus 3. Let's prove that those two are inverses. Well, the first thing you do is make f eat the g function. The f function is x plus 3. Notice me making a parenthesis where the variable was. See, right here. And then I'm dropping in x minus 3. And this seems so easy. Of course, I gave you a softball easy one. These two do cancel each other, and so it's simplified to x, even earlier than usual. Normally, it's going to take a couple steps of simplifying. Then, on the other side, g eats f. Well, here's the g function, x minus 3. And the f function needs to get eaten. So here's the f function going in there, x plus 3. And look at that. That and that cancel. It's x. And then I just have to put an equals in between them. There's your first proof. That's how you prove two things are inverses. You make f of g of x, you make g of f of x, you simplify them both down, and they both equal x. All right, but before we go too deep into that, let's do this warm-up. I was surprised how many people had trouble with this last hour. I made a mistake because I thought the first one was doing f of h of x. No, it's f plus h of x. So you just have to add them together. But don't forget, you need a common denominator. One of them has a denominator of 2, and the other one doesn't have a denominator. Well then, you're going to have to make them both have a denominator of 2 and add it all together. Get a common denominator. All right, I'm going to pause for a minute while you fight your way through these 3 problems. And in a moment, I'm going to have you compare with the kid next to you. So do your best. Maybe you can only get 2 of them done, but try to get all 3 done. Okay, before I have you compare with the kid next to you, let's just make sure you started right. You started with 2x minus 5. That's the f function. And then we're adding the h function. I'm going to do it a different color to make it clearer. H function is x over 2 minus 9. We are adding them. Now, I need a common denominator. So, to get a common denominator, I have to get everything to have a denominator of 2. I can't just divide by 2. That's totally different. But I can times by 2 and divide by 2 at the same time. Times 2 divide 2. Times 2 divide 2. Because you can times by 2 and divide by 2 at the same time. That makes it just like you're multiplying by 1. Okay. So then this becomes just 2x. Wait, wrong idea. Don't cancel them out. I just put them in there. I could cancel them out, but that'd be dumb. 4x minus 10 over 2 plus, that's negative 18 and an x there, so it's x minus 18 all over 2. And then I got to get I've already got a common denominator, so now I got to go 4x and x makes 5x. And these two make negative 28. 5x minus 28 all over 2. Do you get that that was just adding two things and it was really algebra? I mean, like, what's the concept? Add two things. The concept isn't hard. It's the algebra. That's why we work on the top 20, because algebra like that is what brings you down a lot of times. It's not like that was hard, it was adding. It's just the algebra of it made it hard. Okay. And now, if you haven't already, make the h function eat the f function and simplify it down. And last but not least, make an inverse, which means the x and y's flip, and then you solve it, you know? All right, how many of you are already done with 2 and 3? All right, I'm going to give you another about 30 seconds for you to try to get as much done as you can, and then I'm going to ask you to compare 2 and 3 with the kid next to you. Okay, so here we go. H, 8, and F. Here's H, and I'm going to take that, write it down with a x over 2 minus 9. Replace the x with a parentheses. I'm telling you, if you don't have those parentheses, it's going to bite you over and over and over until you finally learn that that matters. Now I'm going to drop the f of x in here, 2x minus 5. The reason it's deadly is that sometimes it won't matter. But then at the moment you least expect it, the parentheses mattered, and it'll hurt you. All right, so now common denominator here is, put this over at 2, times this by 2 to make it stay the same, because you got it times by 1, really. So then the final answer is 2x minus 5 and 18. I think it's 2x minus 23 over 2. Yay, okay. And this one, I take g, which is square root of x minus 20. And then I start with y equals there. Then x equals y. Then we add 20 to both sides. X plus 20 equals square root of y. Now, if you tried to square right here, it could have actually worked. It's just going to be gross to have to square the square root of y minus 20. Because you'll have to do the square root of y minus 20 times the square root of y minus 20, which would be an icky foil. But if I square here, some people got this twisted now that we're going to get an absolute value. No, we just squared both sides. That does not cause the absolute value thing. So this is just y. And this is not x squared and 20 squared. It's x plus 20 and another x plus 20. So again, it's the algebra that can get you on these. And there you go. Put up your hand if you had the same exact thing as me. All right, that's not too many, and I get why. It's pretty likely because you just, in your head, when you squared this, something went wrong. So That's what you should have had, though. All right. Now, if you look at this one and you look at this one, would you have expected it to look like this as inverses? No. This is why you don't want to just kind of go, oh, it was plus 3, so I'm going to change it to minus 3. Like, most inverses are not going to be that simple. But how could I prove that they're inverses? F of g of x equals g of f of x, and they both better simplify to x. All right, let's try, there's that rule. Let's try this one. Everybody's please learn how to do this the right way. F of g of x equals g of f of x, and put a line down the middle, and you better get x at the bottom of each column. Otherwise, it didn't work. And if you, and I will warn you, something's going to go wrong in this one where it won't equal x. And as soon as you have that answer, look, it simplified and it didn't simplify to x like I expected it to. Then you're done. Because, you know, you don't have to prove both sides don't equal x. Just if you prove either side doesn't equal x, then you've proved.
They're both f of x.
Is it supposed to be a g of x?
Ah, good point. Yes, but they could actually do this. You would just then have to pick one of them to be g of x. I personally would pick this one to be g. They could give you two functions that are named m of x and p of x. You just have to pick one to be f and one to be g. And even if they're both called f, you pick one of them to be f of x, one of them to be g of x. Because our formula, you don't want to memorize every possible permutation of, like, what if it's r of x and q of x? All right, I'll pause for a second while you try your first proof. Okay, do you agree that it failed? If you don't know why it failed, let me show you. You might have just not noticed a little thing. The f function eats the g. Okay, so here's the f function. 4 parentheses minus 17. That's the f function. It's going to eat this guy over here. So I have x minus 17 over 4. And then you'd think that after these 4's canceled, by the way, you can only cancel one thing at a time. Don't try to cancel more than one thing, because these proofs are all about showing your work. Now you got this, and if you were careful, you were like, wait a minute, those don't actually cancel. Do you get if there'd have been a plus in here, then these would have been perfect inverses? But they wasn't, so therefore it doesn't cancel. So your answer is x minus, I would have accepted this, or if you simplified it, x minus 34. Either one of those. That's proof that you knew what you were doing and that these are not inverses. Because that should have simplified to x if they were really inverses. Next two, I promise, will simplify. Yes?
So if you do the first side and it comes back to not just be x, do you have to show work on the second side?
Yep, as soon as you've proven that it doesn't equal x on the one side, you are done. But conversely, on this kind where they are inverses, I'm telling you, these two are inverses, then you have to do both sides. Just proving one side equals x is not good enough. You have to prove that g of f of x also simplifies to x. Now this one is not going to be fun. This is where precalc comes in, which the concept of sticking a function in a function is not hard. It's the algebra that's hard. I'll pause for a second while you get it set up. Okay, so I started with the f function right here. And then I made it eat the g function, which is 3x plus 1. Oh, wait, it's 3x plus 1 over x minus 2. That's the part where it gets kind of gross. All right. So, hard problem. What advice did Mr. Server give us before he accepted Elon's invitation to go to Mars and he's no longer with us? Well, Mr. Server said, you should see if you can factor it, you should. And the second thing you would say a lot is to clear fractions. Do you see fractions? I see fractions. But did you know to multiply by the denominator, which is x minus 2? Do you get that x minus 2 is the painful part? If there wasn't an x minus 2, this would be easy. So we're going to multiply by x minus 2. We're going to do it right here. X minus 2 over x minus 2. That's the denominator, right? That's what you do. You multiply by the denominator. Now, I'm going to also put in red, I'm going to put in some implied parentheses that some kids still don't know exist. Whenever you have a big fraction, you have parentheses around the top and the bottom of that big fraction. So much algebra. You have to know there's implied parentheses there. Okay, so now, I know this looks like it's going to just be hideous and terrible, but it's really not. Because we chose what to multiply by, this, when you multiply by that, it cancels out the denominator on it. But it has to be distributed also to this. So then what I'm left with is 3x plus 1 with no denominator anymore. Plus x minus 2. Over, this one does the same thing. When I times that on the top, or to the left side, the x minus 2's cancel. So then it's 3x plus 1. Because this x minus 2 and this x minus 2 canceled. Okay, but now I got to distribute it, so I go to the 3. Minus 3 parentheses x minus 2. Now, I know that was tricky, but it wasn't impossible, because I've told you if you can factor it, you should, and there wasn't any factoring. Then you go to clear fractions, and there was a clear fractions. Can you do basic math then? If you can, this will simplify to x. You may not see it yet, but you will after you simplify it down a bit. You can't just cross it all off and say x, though. That'd be a classic. Kid goes, well, I know it's supposed to equal x, so I'll just say x. No, you can cancel one thing at a time. That's the rules on these proofs, because you'll know that it equals x. But you have to show me that your work actually makes it equal x. So what happens here? 6x plus 2. Ooh, and the minus 2 does, the plus 2 and the minus 2 will cancel. So then I get 6x plus 1x on the top makes 7x on the top. And on the bottom, only can have one thing cancel. I'll let the 3x and the minus 3x cancel each other. And you might be like, you lose, server. It's plus 1 and minus 2. Nope. It's plus 1 and plus 6. Because see how negative 3 times negative 2 makes positive 6. And then that's 7x over 7, and so it's x. Look at that. You should be proud of yourself to be in a math class that's that hard. Look at all of that complicated stuff, and it's simplified down to x. Is there any part of this that you want to ask me about? I'd be happy to help. All right, so we simplified the left side down, and we got x. Now, we're going to try the right side. On the right side, we made the g function eat the f function. And then we had to multiply by the denominator. And since we have one on the top and one on the bottom, that's really equal to just 1. So we're allowed to do that. Can you complete the complicated math? Pausing while you try. Okay, we're going to have the lucky person get chosen by the dice of destiny to tell me what to do. And if you get stuck, I'll walk you through it. It is row 5, person 4, Leah. You ready? That times that, when this gets times by this, what happens? Excellent. So then it's 3 times 2x plus 1. Let's do it. What's 3 times 2x and then add 1? 6x plus 3. Very good. Then the x minus 3 times the 1 just makes plus x minus 3. Did I really need the parentheses? No, but I'm trying to be extra careful. So now across the bottom. Who's going to do the bottom? It is Elizabeth G. This times this, what happens? This times this. Good, what do you get left? 2x plus 1 is left, good. And then you times it by the other one, which is there, and what do you get? Okay, you're right, but let's multiply it out. What's negative 2 times the x? Negative 2x. What's the negative 2 times the negative 3? There you go. Now, I tell you that you can make one cancel per line. You can't cancel more than one thing. So I'm going to use this and this. They cancel. Okay, so then I can simplify the top, and I have 7x on top. Over, okay, in this situation, I would have allowed the kid, since they're on separate sides of the line, I'll let you simplify one thing on top and one thing on the bottom. And that'll get us to this, which then is x, which is what we wanted. Cool. That is a proof. I do need to have an x equals x. There. X equals x. That is about as horribly algebraically complicated as it could get. On that note, I want you to see one more of those really complicated things. I'd like you to take that, switch the x and the y, and make the inverse. It's going to have nasty algebra in it, but by now we've practiced clearing those denominators enough that I think you'll be able to clear the denominators and maybe even throw in some factoring and solve this puppy. So x is equal to y minus 3 over 5y. That's the easy part. I'll pause for a second while you try to finish this thing, and then please compare your answer with the person next to you when you're done. You're finding an inverse of the original. How many of you have already compared? Raise your hand if you already talked to them. Okay, if you haven't, are you totally lost or something? If you haven't already talked to them, please talk to them. Okay, so this is the part where, actually right here, some people get this far and they just gotta get stuck. And I heard somebody say this, you gotta just remember that you're trying to get the y alone, and so that's what's really critical is like, what do I wanna do? I wanna get y alone. So you gotta get them to be on the same side, then hopefully it'll factor, which it does, and then y is alone. There's only one y. That means you can solve for it. 5x minus 1 here, 5x minus 1 here, cancels, y equals negative 3 over 5x minus 1. Now, if I was really cruel and unusual, a punishment that's banned by the Constitution, I would say, take these two and prove that they are inverses, but I'm not going to do that. But you could, by doing f of g of x equals g of f of x, and then there's fractions all over the place, and you have to make things cancel, and it would cancel down to x on both sides, and it's true. These are inverses. Can anybody verify they got negative 3 over 5x minus 1? A couple people. That's not many. All right. So I think I need to do one more like that with you because you just saw that one. So this one will go really fast. If I had y equaled 2x over x plus 1. Find its inverse, like we just did, except hopefully it'll go faster this time. Okay, first x equals 2y over y plus 1. If you can factor it, you should, but there's no factoring. So y plus 1 is clearing the fractions. Xy plus x equals 2y. Get the y's to one side. Now, the fastest way is subtract xy on both sides. There's another way, but I want to do it in one step. Now the y's are both on the same side. Don't freak if you put them on the other side, but you then have an extra step. You'd have to get rid of the x. I can just do it in one step. Now y gets factored out, 2 minus x. And this is x, and then divide both sides by 2 minus x. And again, just to clarify, some people are going to have the exact opposite of this on the top and the bottom. Do you get if I want to? I could multiply by -1 on the top and the bottom if I wanted to. I could. So if you have the exact opposite as me on the top and the bottom, then that's okay. It's legal. Who had x over 2 minus x as their answer? Okay. If you didn't, you're having algebra issues. And I would bet you that most of you don't have a good top 20 if you're still getting this wrong. You got to get your algebra issues figured out because this is a class that heavily leans on algebra. This next test is going to have a ton of algebra in it. So over the next weekish, we don't have to test on this like today or tomorrow or the next day. But on Thursday, we do have a test. I don't know if you noticed. It's set up for Thursday of this week. So we need you to learn this stuff with 2 more days of review. Should be good at it by then. Okay. So this is the work time, and there are problems in the next couple slides. This is not a normal looking assignment. Why? Because these take a lot longer to do proofs on. So one other formula that I reminded the other class of and I didn't remind you of yet. Can anybody finish this formula that you're going to have to know for your next test? Domain of the inside intersected with the inside function in domain of outside. Very good. That's going to be the critical formula for finding when you have g of f of x or whatever, finding its domain. All right, cool. Try these practice problems. There is an answer key, and that's all I got for you for today.